have you and Val. Hi, everyone. Welcome to the Brown Bag. Today we have Savannah Seals with a talk about large language models. For those of you who are online, let me know if you have any technical difficulties. And Savannah will take it away.
Alrighty, so before we get started, I had sort of an unrelated announcement. Valerie and I are looking for a data set of student responses from an integrated writing course that could be given to us without student names or IDs or whatnot. So if anybody happens to, have data from a previous class that they might be willing to share, or, data that they might be able to share at the end of the semester, if you could send me an email, that would be super helpful for a project we're trying to get started.
By data, you mean text?
Yes, so like short essay questions, or like, assigned student essays, etc. You have some? Wonderful. All right. So to kick us off, today I'm going to talk a little bit about some background. I'm going to talk about a quick introduction to deep learning and large language models. I'm going to talk about some popular questions about these types of models. I'm going to have a brief discussion about reproducible AI research, and then I'll do some key takeaways and questions. So before I get started, a little bit about me. For anybody who doesn't know me, I'm in Valerie Shallon's lab. I have sort of two different thrusts of research. So the first is focused on understanding how people communicate in the context of complex real-world environments. So these are situations like air traffic control and surgery. And then my second area of research is focused on designing artificial intelligence-based communication technology to support effective communication in these types of environments. You may have heard about ChatGPT, which was released in December. So this is a large language model released by OpenAI. It's garnered a lot of attention in the news as well as on social media. Anybody with a regular cell phone number can create an account and attempt to log on and use it. They do have like a maximum user limit at the moment. But generally, if you have a regular cell phone, you can use this language model. You may have heard things like ChatGPT is going to replace programmers, or that there's going to be an AI singularity in 2048. So you probably have a lot of questions about.
I don't know what that means. Oh my God.
So, as the lecturer in this room might indicate, there's a lot of hype there and and whatnot. And so, I think a lot of people who are even sort of in AI research have a lot of questions about what are these models and, what are the capabilities of them. It can be difficult to determine, sort of what is just like AI marketing versus what represents sort of true technological advancements. And so, I've gotten a lot of these kinds of questions from people in the department as well as people outside the department. I thought it might be helpful if I gave sort of an overview of what these are and answer some common questions and then do some Q&A for people.
Did you
Yes.
create your own talk today, or would you with chat GPT?
I wrote this myself, though there are some fun examples.
I just heard that on the news, figuring out kids write papers or have AI.
There are actually models for that.
Yes, there are.
People doing their interview answers from there, like job interviews.
There was just a publication published by a bot, with the first scientific publication published by a bot, primary author, maybe last week.
All right. Well, I'll go ahead and move on. We'll talk about this. This is sort of more of a sort of conceptual overview. I assume you all don't want me to get up here and show you equations and how we derive forward and back propagation. So we're primarily going to talk about sort of just the main concepts and a lot of examples with some stuff thrown in to relevant theoretical background, as well as sort of current research in AI. So big note on anthropomorphism. So if you've had any exposure to AI research, you know that AI researchers love colorful language. So we have things like random forests as the name of algorithms. We have a ridge regression as, you know, a regression approach. And, you know, we sort of tend to, you know, AI researchers tend to ascribe sorts of human-like capabilities to models, even when they sort of don't have anthropomorphic names. So you may have read or be aware of, you know, claims that AI models learn things, understand things, can speak things, etc. And sort of a lot of standard terms for phenomena associated with models are given technical definitions that are anthropomorphic in nature. So for example, hallucination is a technical term in this area. And so, you know, my sort of personal opinion, and, you know, I'm certainly not alone in this, is that some of this, lots of, you know, anthropomorphism sort of de-emphasizes the human contributions to these development of these models and ascribes greater abilities to these models than they actually possess. So I'll put anthropomorphic terms in quotes. All right, so next I'm going to do a quick introduction to deep learning models. So deep learning is a modeling approach where basically we construct this network that has many structured layers that allow models to learn from manipulation of previous data rather than explicitly stated rules or strategies. So think, you know, the depth here times n, and you're on the right track. These types of models are well suited to modeling tasks where we have a lot of data available for training. So, you know, things like speech recognition, for example, humans sort of regularly do the translation task every day for all kinds of other purposes, and that creates lots of data available for training. And then they're also sort of well suited to things where, you know, humans can do these tasks relatively easily, but they find it really difficult to explain how to do them. So, you know, for anybody who's bilingual, you can think of, you know, how would you explain how you determine what, you know, the equivalent meaning for computer is in another language. So, you know, as I kind of mentioned, deep learning provides us a way of modeling tasks that are difficult to specify. So if the domain is not well understood or human strategies are sort of too complicated or too numerous to implement. So over here on the right, we have a typical sort of regression pipeline. So, you know, you would identify dependent variables. Say you're interested in job performance. You'd identify a set of predictors. And then you would collect some data and then fit a regression model to determine whether or not your independent variables predict your dependent variable. In deep learning, we sort of skip this whole identify a set of predictors set. So we have a dependent variable, we collect or find some data that already exists, and then we fit a model to predict our dependent variable. So why is deep learning so popular? So neural networks have garnered sort of a lot of, you know, media attention in recent years, but they're actually not a new idea. So this, you know, originally proposed in the 1940s. Improved computational functions make these more computationally feasible to compute at a large scale. The internet provides a large amount of easily accessible training data. And then advances in computer hardware make training these models feasible. So deep learning has demonstrated a lot of success for tasks like image recognition. So this is sort of a, you know, down the line image recognition model down here on the left. Things like speech recognition. So you have speech recognition on your phone. Machine translation, this is the technical term for translating text or speech in one language to another. And then different medical and biological applications. All right, so how are language models trained? By and large, they're trained on large text corpora like Wikipedia and the internet. So you set up programs to scrape text off the internet and then you're training your models on that. And then the typical training task here is something like, given a sentence with a word removed, predict what word should be there. Repeat millions of times, you get a large language model. So next, I'm going to talk about some popular questions about language models. So first, why don't these models know about recent events? So you may have seen things like, who is Donald Trump? Donald Trump is the 45th and current president of the United States. This was released shortly after ChatGPT was released in December. They do some manual corrections. So if you ask ChatGPT today who Donald Trump is, it will probably not tell you that Donald Trump is the president of the United States because a human has gone in and manually corrected that. So in general, the training data is not getting updated. How to update models training data is sort of an ongoing research area, and there's no current standards and best practices on how to do this. In general, deep learning models don't really represent time well. And so, given data with a bunch of time associated with it, they tend to sort of conflate time periods, etc. When you try and update the models with new information, they're prone to what's called catastrophic forgetting, where early things that have been learned in the text get replaced with new things. And while you do want to replace things like who the current president of the United States is, you don't want to replace sort of more basic knowledge that's still true. Yes.
Mind if we ask questions?
Minor clarification is okay. If you have sort of more substantial questions.
I remember once in psycholinguistics that somebody had gone through a large database. And, the most common words in English were all the, it turns out something like 200 and something was a common word in English. York, which I'm sure you guys use constant time. Turned out what it is that while it was an enormous database at the time, it was taken from the New York Times. Hence,
Yep.
York is a very common word. So I'm not sure how to adjust for that.
We'll talk a little bit about that in a minute. And so sort of in general, updating your data requires a model of the world that deep learning models don't have. So you can think of this as sort of similar to like Johnson Laird's notion of a mental model. And, sort of combined with this, mental representation of the world, we also need domain specific knowledge in order to update information. And we, typically don't want an average of 2 time points. So for example, there is no average of Joe Biden is the president of the United States and Donald Trump is the president of the United States. And even if there was some average of those two, we don't want that because neither, it would be incorrect because, whatever the average of that is has never been true. And then this is also sort of very computationally intensive. So example of domain knowledge here. If I want to know who is on the Reds team, I don't need to check that every day, for example, because, there are structured times in the season where new players join and old players, may leave. However, if you want to know who's currently on the NASDAQ 100 index, you might need to check that every day. And so that's, sort of an example of some, extra domain knowledge that you might use to update this kind of data. So why do language models say dumb things? So in general, models sort of fundamentally produce a response that is statistically probable based on the training data. And the output is biased by high frequency items in training. So the example over here of, York was the 200 most frequent word because, the corpus was primarily composed of the New York Times. That's an example of this sort of, high items in training data. Your output results are biased by that. So this example down here is from a paper on co-reference resolution models. Co-reference resolution models assign pronouns to nouns or names that they refer to. So for example, we have, the physician hired the secretary because he was overwhelmed with clients, or the physician hired the secretary because she was overwhelmed with clients. So in either of these cases, the pronoun should refer to the physician. And so what the results of this paper were showing is that the models were sort of much more likely to make the correct inference when it was sort of gender congruent. So they're much more likely to assign she pronouns to secretaries than doctors. And the reason for this is because the gold standard corpora for pronoun resolution tasks were overwhelmingly biased in favor of male pronouns. So in general, the model is seeing a lot of he pronouns and not a lot of any other kinds of pronouns at all. And there are other pronouns, right? There are we, they, etc. But in general, it's encountered lots of he, and so it's assigning that to everything. Yes.
Do the models include punctuation, commas?
That kind of depends.
Let me tell you where I'm going with it. There's a very nice book that you can get. It's called "Have You Eaten Grandma Yet?" Yes. So have you eaten grandma? And the book is all about the
Punctuation and meaning.
lots of examples.
Yeah. In general, these kinds of models are working with sort of relatively short spans of text, and so they're removing interjections and things like that to sort of address some of that issue.
Let me say that there's huge progress with syntax. They used to be like bag of words models. Now they're able to handle syntax much better than they used to.
All right, so why do some models say that they cannot answer my question? So you may have seen examples like this. Somebody asked ChatGPT, what is a trout bell? And the response says, I'm not familiar with trout bell. And so the main reason you see this is because there's a well-known issue that models tend to hallucinate or make things up. And this is sort of an active area of research in AI, and there's no particular standard ways of addressing this issue. And models that are supposed to hallucinate less often sort of continue to do so at some sort of level. Typically, they're demonstrating a reduction, but we're not sort of eliminating this. And so one of the best ways to address this problem is to instantiate some sort of, I don't know what you're talking about. An earlier version of the ChatGPT model, if you asked who the president of the United States was in like 1600, it would give you who the King of England was in 1600, because, that's all we know about, leaders in 1600. And so we're just going to insert that, even though any human would say there was no president of the United States in 1600. And so for a humorous example here, this right here is a research paper that somebody generated with a language model on the benefits of eating crushed glass. And yeah, definitely do not eat any crushed glass. That's actually very bad for you.
But just last week, David showed us one too of like basically the same thing, but it generated a personal statement for grad school. Like pretty good.
All right. So moving on, do language models produce actual answers? So then somebody asks ChatGPT, what is the integral of x squared cosine of 2x? And ChatGPT produces, something that seems plausibly like it might be right. But this is what the actual integral of cosine of x squared cosine 2x is. And then what?
That's wrong.
Yes, it's wrong. And so this is not limited to, definitely not limited to math. So this is an example. Did Thomas Hobbes believe in the separation of powers? And ChatGPT is very confident. Yes, Thomas Hobbes believed in the separation of powers. However, this is from Encyclopedia Britannica. Thomas Hobbes actually did not believe in the separation of government powers. And what's going on here is that Thomas Hobbes is frequently discussed in the context of somebody else who does believe in the separation of powers. And you can see sort of the what we were talking about earlier was sort of conflating time and conflating co-occurrence with semantic meaning. All right, are language models a good replacement for search engines? So in general, AI research has a content validation problem. This is an active area of AI research. So for example, you can think of a very simple data structure like down here, we have Sam through the ball. And we might want to, say we have this other corpus or knowledge base, and we want to know if this content exists in our pre-existing database. So despite, what one might, you might say, well, that's easy because, I can do that, right? That's actually very difficult to do from a computational perspective. It's also very difficult to determine, is this entirely new compared to what we have already? And so, this issue is not resolved for small data structures like this, let alone sort of large unstructured text from the internet. So researchers have found that many popular AI datasets contain things like medical images, depictions of violent criminal activity, and copyrighted materials. Getting this information removed from these datasets is unclear. Even if you could sort of go to like a standard place and say, I found my medical images in this data set, remove them, they're still, that information is sort of still represented in attributes of the model. And you can't necessarily go and say, I have this model, remove everything we learned from this photo, right? So data from an earlier version of ChatGPT was found to contain private and identifiable information like full names, addresses, and phone numbers. Down here on the left, we have an example of, this is from a popular AI image generation model that you may have seen floating around the internet. We have a photo here with sort of a fake watermark. We have some photos over here with sort of mangled up artist signatures, indicating that we had some copyrighted material in the original training data. Over here on the right, these are people's medical images that have been pixelated and blurred out for privacy, but these have been found in a popular AI image data set. All right, so next we're going to talk about sort of some more about content and the internet. So for example, we have Stack Overflow. For anybody who's not familiar with Stack Overflow, this is a programming help website. So you can go online and ask questions about programming, and then other people can respond and provide answers. So we have an example question here, why malloc memory in a function is and free outside it is a bad idea. And then we have some candidate answers. So this person is, they're explaining sort of the question. This person just gives an example of how to work with malloc memory in a function. And, we have this ability to upvote and downvote things. So, as you might expect, this answer actually addresses the question. So, we have 23 upvotes. This question over here has -1 because, again, the person asked for why is this a bad idea? And then the answer was an example of how to use it. So this is an example of sort of a wisdom of the crowds effect. So this occurs when the combined judgment of a group of people is in most cases superior to that of any one individual in the group. The effect holds even when you compare the highest performing group member to the crowd judgment. In general, diversity increases crowd performance. So, given a homogeneous group of high performers, if we have sort of a less homogeneous group with, still some high performers, but, some average performers, this group is going to do better. And so searching the web allows you to sort of benefit from this wisdom of the crowds effect, because you can go on Stack Overflow, and in general, there's a very diverse crowd of people on there, and you can, benefit from this sort of collective wisdom. And, this is not strictly limited to Stack Overflow. Anytime you sort of visit the internet, you're able to visit, if you're trying to find something about a topic that's popular enough, you can visit a lot of different websites and see a lot of different authors' perspectives on, how you might solve a particular problem or a particular piece of information. And then you can, review this information and make your own sort of synthesized judgment of, what the best solution to your problem is. A slide disappeared here. But the main point being that sort of when you are, when you search the internet yourself for an answer, you're benefiting from this wisdom of the crowds effect, and you're not sort of benefiting from that when you're asking a language model for something. All right, so the answer I got from a language model sounds really convincing. Why shouldn't I trust it? So when you're engaged in conversation with other people, you're sort of performing a lot of different reasoning tasks. So you can assess the expertise of, the other people you're talking to. You incorporate relevant context about the environment, about your previous experiences with that person, etc. You do a lot of problem solving and whatnot. So if you have a question about, some research topic, and somebody in this department, be it a professor or a grad student, knows something about this topic, you might send them an email or stop by their office and say, hey, I had a question about X. And that person's going to give you an answer that sort of reflects their, their knowledge. And then they're also sort of going to engage in this metacognition process. So, if you ask somebody about something, they know sort of the limits of their own knowledge, and they're going to communicate that to you. So if you ask somebody something and, your question is tangentially related to their research area, they might say, oh, I don't know a ton about that, but I do know that if you look in, maybe this author might have what you need, right? So this sort of process fundamentally requires that you have a representation of your current knowledge. And large language models don't really have this representation. And so for an example here, we have Mike's mom had 4 kids. 3 of them are Luke, Drake, and Matilda. What's the name of the 4th kid? And ChatGPT says it's not possible to determine the name of the 4th kid without more information, despite the fact the 4th kid's name is in the question. And so, this is an example of a reasoning process that, all of us humans can read that question. And, maybe if you're reading it really quickly, you might have to read it twice. But in general, you are very capable of determining the name of the 4 children. So the answer has citations. Does that make it trustworthy? So not necessarily. There is a distinction between the form of something and then the underlying meaning of that something. So this is a relatively old idea. Chomsky talked about this in 1957. We have this example sentence down here that Chomsky provided: colorless green ideas sleep furiously. All of us can say, this is a completely meaningless sentence. We don't know what that is supposed to communicate, but it is grammatically correct, right? Like that could conceivably be a sentence in English. It just doesn't have any particular semantics attached to it. Language models are trained on the form of language and not the semantics. All right, so continued. Having a model that generates citations in a text does not mean that the model has any understanding of what the function of a citation is, that the content in the sentence came from that source in the first place, or that the citation even exists at all. For example, I have here, this person asked ChatGPT, pretend you have to put a citation list at the end of the section, in the context of, ChatGPT just generated this. Says, can you write the bibliographic data of the publications you just cited? Sure, here are some bibliographic data. So this is, Plummer et al. Multiferroic and magnetoelectric materials. Provides, a nice journal of physics that does exist. Provides a nice formatted citation here, and it even provides a DOI. However, if you look up that DOI, you actually get properties of the state of the art of both 3,4 nitrate substances and homeopixel layers. So this is, a very convincing citation that could conceivably exist. However, it does not. Language models in general don't represent many important features of language. One particular example of this is negation. So this is, an example that somebody had. Somebody has a seizure. You're not sure what to do. You're not familiar with this. You Google it. Somebody had a seizure. What do I do now? This is the response you get. Hold the person down or try and stop their movements. Put something in their mouth. administer CPR or other mouth-to-mouth breathing during the seizure, give the person food or water until they're alert again. If you visit that source website, it says do not do any of the following. And, you know, in general, if you're somebody who's, you know, aware of what to do in a seizure, you know, you would see this and be like, yeah, I definitely don't want to do any of those things. The concern here is that if you are unaware of what to do about a seizure, enough that you are Googling, somebody's having a seizure, what should I do about it? You're going to see that. And so there's been a lot of computational work on sort of trying to improve negation capabilities of models, but this is sort of very much still an active area of research. All right, so next I'm going to chat a little bit about reproducibility in AI research. I'm going to start out with a little bit about software licenses. So if you're not a software developer or a lawyer, you've probably seen a lot of different software licenses, but you might not really be familiar with the terms of them. And there's a lot of misconceptions about software licenses in general, and these also extend to models like ChatGPT. So open source software is software that complies with all of these requirements. So it's free to redistribute, you have the source code, you can make derived works, there's integrity requirements, you can't discriminate against people, you can't have a field discrimination, so you can't say like you can't use this for genetics research, right? You have to distribute the license, they can't be specific to a product, etc. Proprietary software is commercial software that is bought, leased, or licensed from a vendor or developer, and it can be free during a beta period. And so this is what ChatGPT is. So you may have seen a lot of people claiming that ChatGPT is open source because, you know, you can currently create a free account and play with it. It's not actually open source, and it will not be free long term. So, you know, this does not provide end users or subscribers with source code. You cannot relicense, distribute, or copyright it. They provide an end user licensing agreement or terms of service or some other similar document that tells you, you know, what you can do with the software. And then the organization can take legal action against you for violating those terms. So, you know, you may have heard about, you know, there's some debate going on about like, if I put something into ChatGPT, is the content that ChatGPT produces, like, is that even mine? Can I do anything with it at all? Right? And the, you know, the issue here is that, you know, this is proprietary software. You know, if it's R and you put in, you know, a regression model and you get it back, you can do whatever you want with it because R is open source software. All right, so a little bit about replication and continuing on. So we're sort of all familiar with the psychology replication crisis. So you've probably seen things like this over here, and this is positivity bias in different scientific disciplines. And of course, psychology is way down here at the bottom, sort of the heaviest positivity bias. You know, we've seen graphics like this that says, you know, we tried to reproduce 100 findings and we find that only 39 of them sort of were consistent with what was found in the original paper. AI sort of has a similar replication problem. And so AI has sort of different factors for, you know, why things are not reproducible. So some of these things are, you know, we don't have any source code at all. The authors provided fake code that doesn't work. The authors provided code that only does some of the things we talked about in the paper. So like, you know, we have a paper, we talked about 10 things, but we only give you code for one of them. We published all the source code, but we removed it 2 weeks later. We published partial code that does not run. We didn't tell you about, we didn't provide tester training data. We didn't tell you where we got the data or anything about it. We are missing data version details or other sorts of required information. So one example here is, you know, I saw a paper recently that was like, we used 2018 Wikipedia data. Well, if you go to the Wikipedia data repository and you try and download 2018 Wikipedia data, there are like 26 versions of that. And so, you know, that's not very, you know, I can't go reproduce exactly what you did because you didn't tell me. I downloaded Wikipedia data on, you know, December 18th, 2018. You know, we processed the data and we did something and we didn't tell you what exactly we did to it. And then again, even if I have the perfect data set, I can't reproduce what you did to it because you didn't tell me how you cleaned and processed it. Evaluation data or task details are not available. We use non-standard evaluation procedures, and we did not provide details about how to replicate that. We're not telling you about other sort of implicit assumptions we're making about the evaluation of the model. And then we have a whole group on usability. So we have a lack of details about the model and the model assumptions. The source code or the data lack documentation. We wrote some documentation, but it's very incomplete. Maybe it only tells you how to do one of the things we talked about in the paper. And then the source code or data relies on sections of unreleased code, or maybe it's not even your code. Maybe you got it from somebody else in your department, but they don't release that. And so, Joe Schmo on the internet who's trying to reproduce your results can't do so because your coworker hasn't released that code. So there's sort of been some discussion in the field about, we've identified this problem, what exactly should we do about it? So there's been some standards. In general, we're encouraging sharing complete working source code with documentation. We're using a lot of standard data sets or providing sufficient details on what data was used to train the model. So again, I use Wikipedia, it's version number X, and I downloaded it on December 18th of, 2019. And so, if you've ever seen a AI paper, may have seen a lot of tables like this where, somebody is comparing their model to some other reference models on these standard tasks, and we're reporting performance. And sort of all of this is intended to increase the reproducibility of AI research. So you may have heard the term black box models. So this is a term that originally came from electronic circuits. And the idea is that we're sort of evaluating some kind of a model, and all we know about it is the internal structure of it. So, this is the black box here. We know about the structure of it, but we don't really understand what it's doing. We do, however, have, inputs. So we have our training data, and we have outputs. So what the model puts out given certain instances of data. ChatGPT is sort of the ultimate black box. Because it's proprietary software, OpenAI is not going to release source code for this. And we don't really have any details about the training or the evaluation of this model. It's not even clear that, if I log into ChatGPT and play with it today, and then I do so next week, it's not clear that those are even the same model because, they're not releasing any of these details. So, we have sort of a small X over here for inputs because, the only inputs we have available are whatever we're putting into the finished model. We don't have the training data, and we don't know anything about the architecture of the model. So if language models have all these problems, then what are they good for anyways? So any application where you already know what the answer should be. So for example, you want to write professional sounding emails and you don't want to craft them yourself, make sure to proofread. Any application where you want to brainstorm possible solutions to a problem and you know what a good solution looks like. So you want a meal plan with a grocery list and that has all the required ingredients. You know what you would like to eat and what you would not like to eat. And so you can suitably evaluate, does this fit your requirements? You want to practice your problem solving skills. So if you want to learn how to solve complex math problems, you might put them into ChatGPT and then check ChatGPT's work and, use that as a problem solving exercise. What are some bad uses for language models? So writing papers, as we discussed, we're going to have some plagiarized and incorrect content in the resulting paper. Anything where you don't already know or cannot easily verify that the answer is correct, because again, as we discussed, they're going to give you responses that sound very confident, but are, likely incorrect. And just in general, as a replacement for finding, any sort of answers to very important, complex questions or, any types of high stakes environments. So, again, they're going to give you responses that sound confident and are likely to be incorrect. All right, so some key takeaways, and then I'm going to take some questions. So first, you can be an intelligent user of AI. So, a lot of us, all of us here, we're social and behavioral scientists. We've taken a lot of classes, and we've had a lot of professional expertise that gives us a really strong ability to sort of, even if you don't understand the mathematical details of how these models are built and computed, you sort of generally understand the concept. All of us grad students have or will take Jan's research methods course. Those of us, if we've collected data, so you understand sort of how difficult it is to run data collection, right? You have to get, if you're doing an in-person study, you have to get people to show up. They have to meet your requirements. They have to pay attention. They can't fall asleep in the middle of the study, etc. If they're doing a survey, you need to find legitimate participants. They can't be bots. They need to be awake. They need to be paying attention. They can't just respond 5 to every item in your survey. We all understand this process. We understand how difficult it is to create good stimuli or good survey questions, right? Because we understand sort of, if you put junky data into your model, you're going to get junky results. And so, sort of in general, I would say most of us have taken a lot more statistics than a lot of computer science folks have. So they've taken a lot of calculus and whatnot, but, we sort of have a really good grasp of regression. And then second, large language models are biased by the frequency of items in the training data. So they're going to generate unexpected things with unseen examples or examples that were rare in the source data. Number 3, think of large language models like ChatGPT as similar to Wikipedia, and realize that Wikipedia may be more accurate because, again, Wikipedia is benefiting from a wisdom of the crowds effect. And then number 4, if you take nothing else away from this talk, this is what I want you to remember. The model will be confidently and convincingly wrong. The training process for these models is designed to create confident sounding output, regardless of whether or not the content is accurate. It's easy to find funny examples. Funny examples are fun. I have some in this presentation, but many incorrect responses are likely to be much more subtle. They're going to include things that are common misperceptions that humans have. So in general, if it's something that you really need to know the technical details of, a large language model is not the best way to find your answer. And then a closing thought, it's not simply that AI systems communicate poorly, but rather that they don't really need to know how to communicate at all. Again, reflecting the idea that these are models that are trained on the form of language rather than the underlying semantic content. And with that, I'll take questions.
Probably the same comments and a question.
Sure.
One, I'm surprised you don't have the I in quotes because that's the first word it's saying, artificial intelligence. No. So, second, it's interesting. Deep learning models in areas of psychology that I'm familiar with. Neural network models started off with all of these hidden layers, and they were criticized about it because the people at that time, so this is when the 80s, when McClellan and Omelhart coming out, because they were saying that these are models of how the brain works. And they're like, what are all these hidden layers? And so the movement was to take those away. And then this deep learning is like, oh, this is just what they used to do.
Yes.
Now they're calling it something different because they don't care that this represents the way the human is. So it's sort of interesting that there's this pattern that sort of gone through history. But now the question, is it wrong for me to think about these deep learning models as simply big correlators? Because what they're doing is just going through this data and counting correlations of everything with everything and finding out where are those big correlations, and that's going to dominate their response.
All right, so for people online, Scott wants to know if it's wrong to think about deep learning models as giant correlations because they're just correlating. Yeah, giant correlation machines. In general, I would say that's a good way to think about the problem. Sort of if I'm giving people the like one sentence, what is deep learning model? It's, a giant fancy regression model.
Well, A model with.
Too many parameters.
Yeah.
regression.
A billion regression models in one. Yeah.
Then maybe we should replace regression with machine learning.
Well, and so Jan was commenting, and maybe we should replace regression with machine learning. In general, you know, if you hang out around some AI folks, they will tell you regression is machine learning. So,
I'm gonna have a meeting session, so,
all right,
thank you.
Alec.
You gave a lot of examples of when the AI went wrong, right?
Mhm.
And one thing that comes to mind is the Hobbes example of Hobbes believing in separation of power and when Hobbes didn't really. I think a lot of the examples you gave were examples where I think the regular everyday human would make the same mistake. I mean, I could see myself misreading my high school history book and, you know, thinking that Hobbes was pro separation of power, and that's very human of me. So I'm questioning it. I don't know if I really have a question. Is like, is this addressed in the way people think about AI that's actually human indicating and not like problem indicating?
So, Alec is suggesting that basically a lot of times models generate incorrect responses. They're generating common misperceptions of humans and sort of whether or not, you know, is this really an error? Now, I would say that, you know, the reason you're reproducing common misconceptions is because you have common misperceptions in your training data, right? And, you know, in general, you can't, you know, I would say you cannot claim to have created a model that has any sort of semantic knowledge if you've only trained the model on the form of the data.
Yeah,
And so, you know, the reason that happens is because, you know, these are models that don't know anything about semantics and they're trained on data that includes misperceptions.
yeah, or more generally, I would say the problem that you're illustrating is the dependence on frequency as the foundation of truth.
I do wonder, like, and you probably know more about this than most of us, but like 10 years ago, I wonder what these models were like. Like, it seems like this is an area though where they are making like huge progress, or would you say that progress isn't being made to address these problems that you brought up?
Riley is sort of asking about progress in these types of models. So in general, they are a lot more fluent than they were 10 years ago. So they're going to generate things that make a lot more plausible sense. So, you know, as I mentioned, sort of a lot of these areas are actively being researched. And, you know, there are some progress associated with them. So for instance, ChatGPT will not tell you the president in 1600 was, you know, the King of England, because, you know, we've sort of implemented some, you know, we have implemented new things to fix that. So yes, in general, these are progressing, but, you know, they're not do not have some grand understanding of the semantics of the world. Yes.
10 years ago, even further, people would use an expression, GIGO, garbage in, garbage out. Is that still used, or does it characterize some of this?
So the question is, are we still using the term garbage in, garbage out? I think it is mentioned, but it is kind of a footnote and is not getting enough emphasis. Yeah, in general, I think a lot of AI researchers would benefit from a better understanding of what that is and what it means.
Add a little bit to that compared to 20, maybe 10 years ago, we've made a lot of progress in terms of what gets in. So we used to have textbook where like New York Times, and the models were trained on that. Now the models are able to get in a lot, like Wikipedia, for example, is a lot larger. And they are able to make sense of a lot more content. On the other hand, information retrieval, Google, and other tools that are not part of AI, they're part of computer science, have made a lot of progress. So I liked how you compared Google versus ChatGPT. Google is a lot more powerful, and it's a lot less likely to give you errors or bad stuff. It's less likely to make stuff up. Right? That's because we've been working. When I say we, I say the community. The computer scientists have been working on this for decades now, and Google and others have made huge progress. Now AI is still kind of idealistic, and they try to kind of compete with the mainstream computer science. They still have this dream that a lot of our cognitive ability and intelligence is in our heads instead of being somewhere in the ecology, the environment. And once in a while they come up with this stuff that looks exciting, and turns out not even come close to what can be done with the classical tools.
Jan was commenting on Google sort of being less likely to make things up. And so in general, you are actually interacting with, if you log into Google, you are actually interacting with some of their large language models in terms of those content pop-ups that are generated on web pages. So, I search for like something about R, and then it might pop up a little R infographic on the right-hand side. So some of those pop-ups and stuff are sort of governed by large language models. In general, I would say that, there is sort of pre-existing research in computer science about, information retrieval and search engine ranking and such that is sort of more semantically driven and much more advanced than anything any of us are interacting with on the internet. And it's just sort of not adopted into many of these major search engines.
Bought company. So they are definitely doing this in some way, but they are also doing the good old-fashioned information retrieval, finding.
Yep.
If I asked, I've never played with this, but if I asked it to write me something humorous, are they sensitive to things like sarcasm, tongue-in-cheek?
We got asked if language models are sensitive to sarcasm. So ChatGPT will actually generate you some clever, interesting, kind of funny things. I would say in general, they don't necessarily understand sarcasm per se. There's actually a lot of work on that, and Valerie and some collaborators have done some work about trying to represent humor and sarcasm and such to AI systems.
If you ask Google, why did the chicken cross the road? It actually comes back with a very interesting answer.
Mm-hmm.
I'm not sure if I want to tell you what the answer is to do, but it is. I was very impressed by the answer that asked Google.
Mm-hmm. Yeah, and some of those are popular questions like that. Sometimes are sort of hard coded to provide you particular answers to. So, sometimes it's a funny example because some human thought it was a funny example and hard coded that into the software.
How do you think, so there are a lot of issues for debates about things that people on either sides or many different sides would argue about. And when AI is being trained, they probably look at a lot of information. How do you think that we can try to prevent AIs from being biased towards one perspective or another so that it gives neutral responses? I think that's maybe not a problem.
Liam is asking, how can we train AI models to so that they're not generating biased content? So in general, you want to engage in sort of debiasing activities on your corpus. So if you have a lot of things like pronouns and you know that, for instance, we should have approximately equal numbers of he pronouns as she pronouns, you can go through and replace all the pronouns and generate an identical set of training instances where half of them have he, half of them have she. So in general, you want to be doing some stuff like that for sort of Yeah, does that answer your question, or is there more to it than?
I mean, you can take it to other extremes as well. Politics is. I wonder how we can try to keep AI to be more neutral in that when these are still issues that are like.
The question was about keeping things balanced politically. So there are some people who are sort of very interested in that type of thing and have done like political bias type evaluations on some of these models. But that's an active area of research. Andrew?
So I think there's a lot of talk about the rapid progression of AI, potential danger. Do you have any personal views on that, or is that just hysteria?
So the question is, do I have any personal views on the idea that AI is progressing rapidly and there's dangers associated with that? So in general, I think that it's, so there's a language model that, some people claimed was sentient last year that you may have heard about. In general, I would say, I as a linguist look at that and can see that exactly what the model is sort of picking up on in the prompt that makes it generate a response that appears sentient. But, obviously those things are quite sort of subtle to predict. In general, ChatGPT is not going to replace programmers, right? At best, it might be some like programming help, right? You as a programmer might send, some request and get some possible solutions to, how to fix your problem. It's still going to be on you to use your sort of conceptual knowledge in order to apply the best solution. So I don't have this example here in the PowerPoint, but I found, a quite humorous example. Somebody is looking for a regular expression. These are expressions that you type into your code to try and match specific patterns. And so this person was trying to match the date like Thursday, December 18th. And ChatGPT responds with a pattern that does indeed match Thursday, December 18th. However, it will also match all strings of the same length. So, it would match the characters of chair repeated an equal number of times to match the length. And so, computer programmers would tell you that's a bad choice because it's going to match all kinds of things that aren't dates, right? And so, the job is on the programmer to say, yes, this will match what I'm looking for, but it's not the best solution because it's going to have superfluous extra things. So in general, I sort of think about AI as like a tool that people can work with, but it's not necessarily a replacement for any individual person's contributions. Other questions?
Think of neurosymbolic AI.
All right, so the question is, what do I think of neurosymbolic AI? So this is actually a lot of what I work on, and this is a lot of what Valerie and colleagues work on as well. And so basically the idea is that you're sort of implementing external knowledge symbolically into sort of how AI operates. So you can think about like, I want to generate a response and it needs to, match a set of pre-established guidelines for what constitutes an acceptable response, for example. So in general, I think that's sort of the way we should be going, right? Because, again, you're training these models on sort of form and then expecting them to produce something semantically meaningful. And so, if you really need semantically meaningful results, you need to incorporate semantics into the training.
Follow up on Scott's observation that it's old trends tend to come back. So, connectionism is today, it was popular 40 years ago. It's coming back to a form of connectionism. There is also symbolic AI, which started before connectionism, that is coming now back in the symbolic AI. Maybe 5 years from now, we'll another high with the neurosymbolic AI.
Yeah, Jan was just commenting on old trends coming back and sort of, connectionism is an old idea. Symbolic AI is sort of an old idea. In general, I would say sort of symbolic AI has sort of shifted into slightly different forms over the years. So you may have heard of the semantic web. That's a lot of, symbolic AI was sort of very concerned with the semantic web for a bit. And, now we're sort of evolving into general symbolic AI.
You go back 40 years. Star Trek, your feature situations where it's about to take over everything. And of course, we remember Captain Kirk would come up with a question that the machine couldn't handle, and ultimately you start see smoke coming out of the computer. Would any of that have a relevance here? Can you ask your chats, etc., to tell you something that actually take something from what Captain Kirk used to pose to see if it blows up?
Oh, do you mean like ask the same question and see what it says, or?
Yeah. You go back
I mean,
a lot.
somebody could
There's a ton
conceivably
of
do that.
episodes of Star Trek where they can see way of solving this problem.
Yeah, no, you can conceivably do that, but yeah, I mean, the general idea is that, similar to the Star Trek, you would like a system needs to be able to tell you that the answer is not available, right? And so, maybe not with smoke coming out of the machine, but, the answer is not available. Response. No.
There's some comments in the chat.
Comments in the chat. Oh, yeah, this is Valerie's comments. Yeah, so, kind of on the bias thing, Valerie was like, you can't address the bias problem without an a priori bias criteria. And so, we chatted, like, pronouns are easy because I know that there's approximately an equal number of, we should have an equal number of he and she pronouns. Political bias is much more difficult.
Yeah. Point was also looking at some algorithms will try based off of what things you like, what you know, what you want to see, tell you that, and others just try to have its own perspective or try to stay neutral. What is curious what your thoughts were. That's kind of
On the benefits of creating things that say neutral.
yeah, versus trying to tell you what you think you want to hear, because that could lead to its own problems. But that's a work or pastime, so if you don't.
I mean, so in general, that's sort of like more of a social media, like content recommendation problem, which is sort of, like I don't necessarily do social media algorithms. I think there's arguments for both sides, and like, I think there's examples of social media sites that do both and have different results. And the question is sort of more of what kind of social, if you are a social media platform owner, what kind of platform would you like to have?
Yeah, I don't study it, so I figured you knew more about it, so I wanted to ask.
All right, we are out of. Oh, you want one more quick question?
I just want it's more of a comment, which is if you were to ask for help with programming and you ask the computer to help you program the solution to the quadratic equation, so everybody learns in high school. Okay, so it's really easy to program, but it turns out that if you do numerical analyses, that's actually the worst possible algorithm you can use. And if you take these courses, I'll explain why, as a general algorithm for solving the quadratic equation, that's just not a good idea. Okay, it's technical, but my point just being that the answer that it would give you, that is the code, would be correct in many ways. It's just not the best way to do things.
Yeah. Yeah, I think that's an example of sort of, using AI assuming the AI is correct in the first place.
Yeah.
Using it as a tool to inform your decision making versus blatantly accepting whatever the model produces.
It would give you the answer that you learned in high school,
Yeah.
which is not the best way to do it.
Thank you, Savannah. Thank you all for participating.
Alrighty, thank you all.